Hello, this is Mark Tucker.
And this is Alan Furstenberg, and we are Two Voice Devs.
Two Voice Devs. Good to talk to you again this week, Ellen.
As always, it is fantastic to talk to you, Mark.
So, just trying to think about something that we could talk about today, and something that I've come across, I guess, a few times here recently is has to do with training data models. This is something that we did way back in the Alexa and Google days, but maybe we didn't quite think about it like that. But um, labeling data in preparation for training a model.
Right,
So,
and this is kind of an important thing. We talk a lot about large language models and models that have been pre-trained. These foundation models. Um, but there's also this huge world out there of training your own models or even fine tuning your models in some cases. And when
yep.
you're doing this, we have this notion of needing to label data. So maybe we can explore, I mean, just what does that mean?
Yeah. So, if you think about it, data's got to start someplace. You either have to manually create it, right? Or you glean it from something, maybe from a system that you have, or grabbing things from the internet or open source data sets, whether it be books or articles or something. And that's a place to start, but that's just kind of raw data.
It occurs to me, even we've been talking recently about using large language models to create data, but I feel like we're gonna get later. So
Yeah, I think what we're talking about now is kind of more of the foundational models, maybe non LLMs, or the data that might go into training training a model of whatever type it is.
right, so we're talking just basic. We're going to be making a small model for ourselves. We've talked in the past about BERT, for example. So this is creating the data that you would use to train BERT.
Right. Or it could be creating the data that you need to create a spam filter for email or something.
Right. And it occurs to me, actually, saying creating the data isn't quite right. It's more like collecting the
Right.
data and then labeling the data, collating the data, organizing the data.
Right. So untamed or raw data on its own isn't super useful. Um, so so need to figure out how to label it, and depending on what you're going to use the data for, would indicate like how it needs to be labeled. So I thought we could like look at a little bit, some examples, some from the past of doing, my case, some Alexa skills stuff, or BERT or other things, and talk a little bit about what labeling data looks like, or what labeled data looks like, and then talk about ways that you can label data. Some of it, anywhere from manually to using more programmatic approaches to labeling data.
Makes sense.
All right, so I think I'm going to go ahead and start with kind of a good old classic Jovo example. Now, reminding to some listeners who may not be familiar, Jovo is a framework that's been around for years. It's used for creating voice assistants, chatbots, and it's used for doing things cross-platform. Back in the day when you could do Google Actions, you could use the same Jovo project for Google Actions, Alexa Skills, custom chatbots, or whatnot. So, but one of the features of Jovo is this format of specifying what the model is, and all the model really is the training data that you need to train a model. So this file would be fed into Google Assistant, and it would actually use this to train some engine or model behind the scenes, so that later when you're actually using the Google action, you could say something and what you said gets turned into text, and then figures out what the user's intent is. And same type of thing. The same thing worked with Alexa skills. So this same type of model could then be pushed into the process for training an Alexa skill, and in the end, when you use the Alexa skill and you speak to Alexa, then it would do the same type of thing. But just looking through this file, you see that there's an intents section under here. There's some examples of some intents like yes intent, and some samples like yes, yes please, or sure. So like if I were to respond to Alexa and say yes, then it would do a lookup and figure out that yes matched with yes intent. So in code everywhere when I'm trying to do something, I would know that yes intent was the thing that had happened. And so the code doesn't need to know anything other than the user said yes. They don't need to know exactly what they said. I could say yes please, or I would like to do that. It might even be something that's not necessarily specifically listed here, but this is a form of labeling. So you're labeling and saying that this intent matches to these utterances. And then when you're using the skill, it's in reverse. You say the utterance and it maps back to the intent.
Right. When at a fundamental level, labeling something is creating an association or a grouping.
Yes.
So here's where we're saying this set of phrases belongs to this intent. So we're kind of saying they're in many ways equivalent. Not exactly the same,
Yeah.
but they're equivalent in some abstracted data way.
But if you think about like how do you get this list of yes, yes, please, sure, and mapping to intent? The data had to come from someplace. And in a lot of cases, when we're working with Alexa and Google Assistant, things were simple enough that um, you had 10 to 20 maybe utterances per intent. It's something that a conversation designer could think through or user could think through.
Uh huh.
Could be something that came out of usability testing, and seeing what users actually said in certain situations. And that could be, even before anything was coded, you could do Wizard of Oz testing where you would say, I'm pretending like I am the assistant and you are the user, and your task is to do this. What would you say? And recording that stuff. But in the end, if you think about it, you might start off with just a list of utterances. And then the exercise is I'm going to group those utterances into things that map to the same intent. And is you're labeling that utterance to be classified as a specific intent.
Okay.
All right, and I'm just going to quickly go through a few more examples on this file. Um, so we got yes, we have no, we have cancel, we have repeat, start again. So these are just various different examples. Now we get down to this book room intent. And this would be for something that like a room reservation. So I'd like to book a room, I'd like to make a reservation, I'd like to book a room in a specific city, I'd like to book a certain type of room, a king size room, a deluxe room. Um, so notice that this is not only labeling or classifying this utterance as a book room intent, it's also classifying this word or phrase in here as a city or as a room type. And if you come down here, you can see that there's a separate definition of room type is of this room type or city type. Same type of thing here with animals. You can have like a type of animal or a number of animals. Do you have 3 dogs, for example? And so those placeholders for number and animal or for city and room type are then defined separately down here. So for example, here are different animals. So here is a dog, and dog might have synonyms for dogs, puppy, or cat, kittens, or different animal sizes: small, medium, normal, big, huge, large, king, queen, deluxe. New York City, New York, Big Apple, Los Angeles, LA. So these are all ways of labeling either this utterance maps to this intent or this utterance has subparts to it, words or phrases in it that are of a certain slot type.
So in a sense, we're taking a phrase and we can label it in multiple ways and with different parts. So we're kind of saying,
Yep.
if we looked at that that room reservation intent. We could say that hotel room gets labeled with book room intent, but book a room in some city gets labeled with book room intent, but also gets labeled with the fact that it's got a city marker in it, and
Yep.
the various cities each have their own sets of labels. So LA also gets labeled against Los Angeles.
Yes.
So we this introduces the notion of, one thing can get, and in many cases will get, more than one label attached to it.
Correct.
And that kind of goes to another question, I guess I feel like I wanted to bring out, is that um, some things certainly will get multiple labels. So, for example, if we're uh, if we're talking about orange, an orange could
Hmm.
get labeled as a fruit, or it could get labeled as a color. These are both very, valid labels for this word or this thing, and the model may need to know that in some various ways.
Yeah. So, like in this example, there weren't very many phrases. So, I actually have a process where I've got a spreadsheet, and each of the different columns is an intent, and I just type in the spreadsheet different variations, and I from that spreadsheet I generate this file and go on. So, but that's very much a manual creation of training data as
Mm-hmm.
well as manual labeling. Um, because I also have a spot where I can specify, oh, this one has slots, and this is what the different examples of slots can be. And depending on the system that you use, the slots can be open or closed, meaning the the slot values that you provide is the finite list and can only be picked from that finite list, or it could be open and saying find these things or other things that match the pattern where the sentence includes this or is similar to this, and there's a spot for this thing, and find this thing even if it's not specifically defined. But that's kind of more the engine or the system that you use can can treat data differently, the same labeled data differently depending on configurations for the engine or the model when you're running against it.
Okay.
So, but we can think of like a more complicated example. Maybe you have a Google action, you know, back in the day, and as you said something or even typed something, then that phrase or that utterance could be captured, right? And let's say that's all you do is you just capture all the different input that somebody does. Now, if it doesn't match any of the intents, then now you've got a set of data that users are saying, but it's not mapped, it's not labeled in any way. So that's a process where you'd go back and have to go through and figure out a labeling process. But you could, over time, just capturing data in a system, get a whole list of utterances, for example. But that's once again raw data that needs to be labeled before it can be useful.
Right.
So
So these are the cases where somebody says something and it ends up in a fallback intent or whatever.
yeah. Mhm.
The system doesn't know how to classify it. We can go in later, review these, and say, oh yeah, that goes to this intent and this goes to this intent. So there's this manual process of later marking new data edited. Okay.
Okay. So I'm going to go ahead and let's look at a little bit more complicated of an example. So I'm going to go to the BERT-based model example. So BERT is a model, and it's trained on what it calls a large corpus of English data. So then let's go down here a little bit farther. Fortunately, this model card gives a lot of information about it. So you can go down and look at uh, like what exactly the data it was trained on. So it says the training data for BERT was book corpus, which contains 11,000 unpublished books, and English Wikipedia. So if just imagine scraping English Wikipedia at some point in time, excluding the lists and tables and headers, and just taking that data. So then it says, well, how was this trained? So, just grabbing that, you can just imagine grabbing that data from English Wikipedia is just raw data. right? It's, it's just screen
Right.
scraping or
It's
whatever
a bunch of
that data.
words, but they don't. It's a bunch of words, but they don't necessarily connect to anything.
Yeah. So, or in this case, more specifically, a bunch of it could be broken up into a bunch of sentences. But
Okay.
what use is that list of or just raw data of sentences? Well, the idea behind BERT is that it gets fed enough English data that it kind of understands the English language, right? It understands associations of words. It understands. It can do. You can give part of a sentence with some piece missing, and it will tell you the best options for what that missing word should be. But if you take a look at this, it's actually trained on the form of sentence A and sentence B. So it takes, just imagine some page out of Wikipedia and it grabs two sentences out of it. In some cases, it could be a consecutive one sentence right after another sentence, or it could be, two sentences from completely different pages on Wikipedia. So that's sentence A and sentence B. And then it's got these special tokens. So CLS is a token saying this is the beginning of a classification. Here's an example of sentence A, some sort of separator, so you know where sentence A ends. Sentence B, some sort of separator, and that's where you know where sentence B ends. So with the probability that 50% sentence A and sentence B corresponds to two consecutive sentences in the original corpus or data, and then other cases where it's randomly selected sentences. Plus, it limits the sentences to 512 tokens, um, but then it also says 15% of the tokens are masked. So some of the sentences are just complete sentences. Some of the sentences are masked. 80% are masked and just replaced with the special token mask. 10% in the cases are replaced by a random token, and 10% are left with just the original word that was there. And so then it talks about the pre-training. But if you look over at this right-hand side of the model card, you can see
I've
data
got
sets. Yeah, go ahead.
I've got to admit, I'm looking at that and trying to figure out what is it training it with in those cases.
Yeah, that's a good question. That's going a little bit deeper into the data science mystery of it. But as a developer, if we're given parameters that we need to come up with, take raw data and come with data that follows this specific format, then that's the job. Kind of that's the way I'm looking at it from here. But yes, definitely developers can get involved in the aspect of preparing data or labeling data to train models. And then once models are trained, developers can use those models to program solutions to certain things. Yeah, I'd have to dive deeper into understanding exactly how that works and why it's done that way. And there's a whole paper on this type of model, and would go into more detail on exactly what it's doing.
Okay.
Just kind of keeping it still at the high level. You can see over here on this model card, it says that the data sets are the book corpus, as well as Wikipedia legacy data sets. And you could go in and find out some more information about the data. But the last thing I just wanted to do was to show an example. So because have all this data that was then used to train BERT, now you can use BERT to run an inference, and this is going to be a fill mask type of process. And so you could say the goal of life is, and add that special mask token, and then it would go through and find the top things that match. So the goal of life is life, how profound. Or the goal of life is survival or
With,
love or
with
freedom. And so based on the test data, this is what it figures out. Is This is kind of like fill in the blank. The goal of life is, and then it's going to tell you the things based on the data it was trained with, what it thinks should go there.
Okay.
Now, BERT can be used, just kind of out of the box in this way. Um, there's also, I think, something you can do with like sentence comparison, where you can give it two sentences, and it will tell you the probability of it them being consecutive sentences or not.
Right. Uh huh.
What that tells us is that the way that data is labeled as input into model training affects how you can use that model for inference to get data out of it.
Well, I think what's interesting. I mean, I'm looking at this card and looking at the text on the left hand side,
Mm-hmm.
and it has this interesting comment of this means it was pre-trained on the raw text only, with no humans labeling them in any way, because that suggests that the while there was no labeling, what was created from this sort of pseudo labeling
Yeah.
were this notion of we're labeling one sentence as following another. That's kind of labeling in a way. We're saying here's an association. It's not
Yes.
labeling in a traditional data science sense of the word, but it is saying here's an association, which is
Yeah.
what
Now,
labeling is.
yeah. And this is a nuance that I'm going to need to investigate a little bit more. It's pretty clear to me when you have raw data set and then you generate some sort of a JSON or YAML file or some sort of structured data file, as you know, through some sort of process, and then that file is the thing that's being fed into training. That's pretty clear to me that there is labeling going on. Right now, if you manually create that JSON file, for example, or you have some code that goes through and evaluates each of the different, sentences in this case to determine something, then that is also a form of labeling. It's a lot clearer to me if I think of like there's this intermediate JSON file or structured data file that goes from raw data to structured data to, input into the model training. But what this seems to, maybe this hints at, is that part of the training itself was just taking in the data and kind of just in time, it was slapping that mask tag on certain parts or certain percentage of the sentences. And in certain cases, it was grabbing consecutive sentences. In other cases, it wasn't. So maybe it was just a kind of a just in time reading data in, just in time labeling as it was then feeding it in to train the model. So that seems to be like a lot more of an automated labeling process than kind of the Jovo example we looked at earlier.
Okay.
So now, if you look at different ways of using then the BERT model itself, you can fine tune that with additional data, and you can turn it into something else. So for example, you can take this basic model that was trained on sentences in the English language, then feed it into the training data some version of this where it's mapping utterances into intents. Let's just do the intents to utterance mapping. You could then fine tune BERT to be an intent classifier. When you pass in a sentence, it could then say, I can match this utterance in with this intent, or I can match things that are similar to the utterances that maybe weren't exactly trained on, but because it has a wider knowledge or grasp of the English language or word associations in the English language, then maybe some untrained utterances can still map to intents.
And
So,
this is why we like using these sorts of things as foundation models, because we
yes.
can build on them. They provide that basic set of language knowledge, and then we can build on it to provide more specific knowledge.
Yeah, exactly. So using BERT in some case, even though it was originally trained one way, can be fine tuned with different data to tweak it to become something that you want to use. And that's the case for lots of different models. You can start with some other, like even more basic model, like some sort of a model that looks at emails and determines if the email is spam or not spam, right? Um,
Mm-hmm.
that type of things existed for a long time, even before all the latest ML stuff that we're doing. But it's still the the basic concepts still hold true. Um, where you need to have a certain set of data that's labeled as these are good examples of emails and these are spam examples of emails, to then train whatever the engine or the model is, so that when it sees emails that it wasn't trained on, it can classify as spam or not spam.
Right. Okay.
Right. So that's just like an even simpler classification example, but like intent, utterances to intents is just another example of classification. So we talked a little bit about kind of more the automated example of how BERT was trained, where the system turns it from unstructured to structured data as it needs to when it's training the model. We're kind of going into now the middle ground, where maybe you have this raw unstructured data and you want to get it into structured data, but it's so much information that you can't really go through it manually, or it would take a really long time to manually go through it, right?
Mm-hmm.
So I'm going to introduce Snorkel. So Snorkel is an open source library, and one of the main things it does is takes this unstructured, unlabeled data, runs it through code, and then labels it. And notice how not all the data was labeled. So what this library allows you to do is think about if this data contained this thing, and it could be just doing like a regex or searching for specific words or phrases, or other things. You could say
Just have it search for, basically it's kind of search for anything that we can programmatically define.
yes,
So it could be, as you say, it could be a regex pattern, or it could be specific keywords might trigger it, just when
yep,
similar to the intent classification, or it would be length. It would be some combination of things.
yep,
It has this word and it does this, or it's basically offloading. It's basically offloading classification to a program, because we can define that in a bunch of ways, not every way, but in a bunch of ways. And then there's this gray area where maybe a human will need to step in and make a call.
yeah. Or maybe you have 100 million rows of data, and only 50 million of them pass muster, can be easily identified programmatically. That still might be enough data to train your model. So maybe you don't need to do any manual labeling of data. But if you think about this product, this library Snorkel, just think about it as a series of functions that, as each input, it could be a sentence, it could be a paragraph, whatever the unit is that you're breaking things down into to evaluate. It could be a whole email, but it takes that data and it runs it through a pipeline of functions. And the function can say, yes, it matches, no, it doesn't match, or I couldn't tell, I abstain, right? It could be more complicated than that. If there's, I'm thinking of the example of a spam filter, but it's like spam, not spam, couldn't tell, unknown, right? So as it runs through each of these different functions, then different functions could say yes, and some other functions for the same data input could say no, which might determine that it's undetermined, or but you get to define the code that are these labeling functions, and then in the end you've got data that's labeled,
Uh-huh.
or at least a subset of the data that was raw is now structured and labeled, that could be used for something else. Now it does additional things, data augmentation and monitoring critical data subsets. It's not something that we're going to talk about today because we were talking specifically about labeling. But if we wanted to come down here, um, this is just a very simple example. And this library, is in Python, and it's open source. But you could do similar things yourself. You could create your own pipeline of functions that do this. There might be some other libraries and other languages depending on what you use. But in this case, the labeling are abstain, not spam, or spam. So 1, 0, or -1. That's the output of a function. Like if the word my is included in the input data, then mark it as spam. Otherwise, say abstain. I don't know. But then you could use, so this is an example of keyword matches. Here's an example of a regular expression, some sort of arbitrary heuristics, calling some sort of an API, whatever it is. You can create a labeling function that does that, that checks for that specific thing, and then you can go ahead and combine them together. So in this case, here's a list of labeling functions, and goes through and it figures out what the training data looks like for that, and then you can feed that into the ability to fit or train your model, and it uses the input data. So this is the gist of what a tool like Snorkel does. Is it's used to programmatically help you go from raw unstructured data to structured data that can then be used as input into model training.
What's interesting about this to me, and especially since you were using intent classification earlier, is that one of the things that a lot of people early on, as we were bridging to LLMs from the trained language models that we were using, the trained intent models, was a lot. There were a lot of people that were saying things like, "Yeah, I don't really know how this LLM thing is going to work out, but I could get it to synthetically create a lot of phrase data for my
Mm-hmm.
intent." And I could write algorithms that would just, take all of these combinations of words and put them together, and that would be good for intent training. So not just this, but also some of the transformation components of this, I think,
Yeah.
go back to saying things like we can take it in, and we can create that labeling ourselves. So one way that we could create labels, for example, is to take a phrase from our test set
Yep.
and hand it off to an LLM to classify it. If at the end result of this it's abstain, maybe we'll hand it off to an LLM and classify it and say, what do you think this is? How would you label this?
Yeah. Exactly.
But importantly, that's up to us to do. It's our choice whether we want to do that or not.
Yeah.
Um, I think the other interesting thing about this is that this is a great way to say I may have a set of information, a set of data that needs to be labeled, and I've established some rules to do it. And over time, I might learn that those rules are okay, but maybe we can improve them. And I tweak the rules and run them again, and I don't have to manually reclassify everything. I've got a program that's doing it for me. This is automation at its finest. If you
Yeah.
can automate it, do so.
Yeah. Exactly. And one of the things that's encouraging to me about this is that kind of in this rush to do Gen AI and large language models, it seems to be like, oh, you need to learn data science, or you need to learn prompt engineering, or you need to learn, and it's in some cases that you've got a developer that has a certain skill set, and a certain interest area, and maybe they don't have any interest in prompt engineering or creating agents or working on the solution side of things. Maybe their skill set and interest is in getting good quality data to have models be trained on. So this just opens up yet another area where developers can contribute.
So this is all pretty interesting. I think this is an important set of distinctions that labeling is important. It's important in the data science field, even beyond AI. It's important in the data science field just to easily
Yep.
quantize things. But this is a great kind of illustration of where that fits into programming and how programmers who are not data scientists and don't want to be data scientists
Yep.
have an important role to play in this whole thing. And it seems like projects like Snorkel are well founded in data science, but still have that programming component to it, and I think that's useful.
Yeah, I'd be definitely interested in how different programmers are getting involved in this area of data scrubbing, data labeling, whatever it is to assist in training of models. So if you're out there and you're doing that type of thing, you're using tools other than Snorkel or kind of different approaches or something that we didn't talk about, or if you want to reiterate something that we did, just go ahead and get us a contact. You can write comments here in our YouTube or contact us on social media, and we would sure love to listen to you and figure out where you are with this.
And of course, we will share this all another time on Two Voice Devs.
Two voice devs. Thank you, Alan.
Thank you, Mark. Have a great week.
You too.